Why might a tractor, a warehouse robot, and a passenger car soon have to follow very similar cybersecurity rules? These machines come from completely different industries. Historically, they have been designed by different companies, regulated by different authorities, and built according to different standards.
So why are their cybersecurity rules starting to look so similar?
To answer that, we need to look at something that has quietly transformed machines over the last 20 years. Modern machines are no longer purely mechanical. Take a modern vehicle. A typical car today contains hundreds of electronic control units, millions of lines of code, sensors, wireless connectivity, often remote software updates, and increasingly autonomous decision-making.
In many ways, a car is no longer just mechanics.
It's a distributed computing system that happens to move people. Now look at modern robotics. Industrial robots, agricultural machines, warehouse automation systems. They all rely on embedded software, sensors, connectivity, sometimes remote updates, and increasingly autonomous decision-making.
So even though these machines come from completely different industries, they now share something fundamental. They are all software-defined systems. One industry was forced to confront this issue earlier than most, the automotive industry.
As vehicles became connected through cellular networks, Bluetooth, Wi-Fi, and remote services, the risk of cyber attacks kept growing. Cybersecurity experts demonstrated remote vehicle hacks, security vulnerabilities were uncovered in vehicle systems, and regulators realized that traditional automotive safety rules were no longer enough. Regulators introduced a new regulatory framework through UNEC WP29.
The UNEC WP29 framework includes two regulations, UNR 155 and UNR 156.
UNR 155 requires automotive manufacturers to implement a cybersecurity management system. In practice, this means manufacturers must identify potential cyber threats and analyze risks, implement mitigation strategies, and monitor vulnerabilities over the entire vehicle lifecycle. UNR 156 addresses another problem: software updates. Modern vehicles receive software updates after they are sold. So, regulators introduce rules to ensure these updates are secure, traceable, and properly managed. This was a major shift.
For the first time, cybersecurity became mandatory for an entire industry.
Now, let's look at robotics and machinery. Traditionally, these systems were regulated mainly through safety standards. The main concern was preventing physical accidents. But cybersecurity wasn't a central focus.
That is beginning to change, because modern machines are increasingly connected to networks.
They may connect to cloud platforms, remote monitoring systems, and industrial control networks, which means they can now be exposed to cyber threats. And this is why new standards are starting to appear. One example is ISO 24882, which focuses on cybersecurity for agricultural and off-road machinery. What is interesting about this standard is its structure. It includes processes like threat analysis and risk assessment, implementation of cybersecurity requirements, and vulnerability monitoring across the lifecycle. If you compare it with vehicle cybersecurity standards, which define cybersecurity engineering for vehicles, the similarities are strong. Two industries that evolve separately are now using very similar cybersecurity frameworks. But the real reason for this convergence lies somewhere else, in regulation. In 2024, the European Union introduced a new regulation called the Cyber Resilience Act, or CRA. Unlike previous regulations, the CRA does not focus on a single industry. Instead, it focuses on something broader: products with digital elements, or in other words, any product that contains software or connectivity. That includes IoT devices, software products, connected machines, robotic systems, and many other technologies.
The law introduces essential cybersecurity requirements.
Product must minimize attack surfaces, protect the integrity of data, support secure updates, and manage vulnerabilities across the product lifecycle. One important concept is the Software Bill of Materials, or SBOM. An SBOM is a detailed list of all software components inside a product. Why does this matter? Because modern software relies heavily on open source libraries and third-party components. If a vulnerability appears in one of these components, manufacturer needs to know exactly where it is used. SBOMs make that possible. This idea is not limited to Europe. The United States, for example, introduced very similar requirements on software supply chain security. So globally, regulators are pushing towards the same principle: transparent and secure software ecosystems.
When you combine all these developments, something interesting happens.
Automotive cybersecurity regulations like UNR 155 introduce structured cybersecurity processes. Robotics and machinery are developing standards like ISO 24882, and the Cyber Resilience Act creates horizontal cybersecurity requirements across many digital products. Suddenly, machines that used to follow different regulations now share similar principles: vehicles, robots, industrial systems, connected devices. They all need risk analysis, secure development, vulnerability monitoring across product lifecycle, and software traceability. In other words, cybersecurity regulation is quietly creating a shared engineering framework across industries.
For decades, industrial sectors developed their own standards independently. Automotive had its own rules, industrial machinery had others, and consumer electronics had very few.
But as machines become software-defined and connected, cybersecurity becomes a common challenge, and regulations are gradually forcing industries to converge. The result is something we barely notice when looking at individual products: a shared cybersecurity infrastructure emerging across modern technology.
And in the long run, that may reshape how complex machines are designed, from cars to robots, but also transform the supply chain of those industries.